Hey Algebra 2, today we are going to look at lesson 15, interpreting those residuals from a line. We learned what a residual was in the last lesson. Today we're going to talk about what they mean a little deeper. So example 1, calculating prediction errors. The gestation time for an animal is the typical duration between conception and birth. The longevity of an animal is the typical lifespan for the animal. The gestation time in days and the longevities in years for 13 types of animals are shown in the table below. Here's a scatter plot for this data. You have this in your classwork also. We can look at it and decide what type of line we think would fit in there, how accurate that would be, etc. So let's go ahead and fit that line. Here we are. So finding the equation of least squares line relating to longevity to gestation time for these types of animals provides the equation to predict longevity. Remember, the line is your prediction. The dots are actual. How good is the line? In other words, if you were given the gestation time for another type of animal not included in the original list, how accurate would the least squares line be at predicting the longevity of that type of animal? So use a graphing calculator, verify that the equation of least squares line is as given. It would be a great exercise for you to go ahead and predict that. On the previous slide, you would put the, let me look at them. Actually, the first slide, the gestation time would be your X value, so you want to put that into list 1. Longevity would be your Y value, so you want to put that into list 2. And go ahead and do your linear regression. And then you can store it into Y1 using the vars. I would practice it. It's silly for me to do that on the lesson video because you can't see my calculator, but I would go ahead and practice it and see what you get. And then you can graph them both together. Suppose a particular type of animal has a gestation time of 200 days. Approximately what value does the line predict? That means we're going to use our line for the longevity of that type of animal. I have y equals 6.642 plus 0.03974, and I'm going to plug in for x 200. Crunch my calculator. I've got 14.59, which is, we're just going to round that to 14.6. Longevity, so that is in years. Would the value you predicted in exercise 2 necessarily be the exact value for longevity of that type of animal? No. It's predicted. Could the actual longevity of that type of animal be longer than predicted? Could it be shorter? Yeah, it could be either longer or shorter because this is just a prediction. You can investigate further by looking at the types of animals included in the original data set. Take the lion, for example. Its gestation time is 100 days. You also know that its longevity is 15 years. But what does the least squares line predict for the lion's longevity? Substituting x equals 100 into the equation, you get approximately 10.6. The least squares line predicts the lion's longevity to be 10.6, when in actuality it's 15 years. How close is this to being correct? More precisely, how much do you have to add to get 10.6 to the lion's true longevity of 15? We predicted 10.6 for the longevity of the lion. If we subtract that from 15, we get 4.4. So this right here is our residual. We did this in the last lesson. I can show this on a graph. This is his actual longevity and his prediction. So the vertical distance between actual and prediction is 4.4. If I look over to there and look over to there, I can do the subtraction that way also. Okay, that distance is 4.4. Let's continue to think about the gestation times and longevities in animals. Let's specifically investigate how accurately the least squares line predicted the longevity of the black bear. What is the gestation time for the black bear? I went to the table and looked it up. 219 days. So look at the graph. Roughly what does the least squares line predict for the longevity of the black bear? If I come over here to approximately 219, I'd say about 15 years. It says roughly, which is why I didn't use the equation, I just used the graph. Use the gestation time from part A and the least squares line to predict the bear's longevity. So now I'm going to plug it in. I have y equals 6.642, 0.0397 times, what did we say? 219. Crunch those numbers and I get 15.3 years. What is the actual longevity? 18 years. How much do you have to add to the predicted value to get the actual longevity of the black bear? 2.7 years. So that is my residual. Show your answer to part E on the graph as a vertical line segment. Right there. And that would be 2.7, right? Let's do this again for the sheep. So we're going to substitute 154. Do the calculations and I get 12.8 years. What do you have to add to the predicted value? The actual was 12, the predicted was 12.8. I get negative 0.8. That's my residual. Show your answer. Let's see, sheep, that was 154. I'm going with this one. So the distance is below the line, 0.8. It's just a little itty bitty line segment right there. Okay, pretty hard to see on my iPad. So in previous exercises, you found out how much needs to be added to the predicted value to find the true value of an animal's longevity. In order to find this, you've been calculating actual minus predicted. This quantity is referred to as a residual. Residual equals actual minus predicted. You can now work out the residuals for all the points in our animal longevity example. The values of the residuals are shown in the table below. So we did actual minus predicted and got all the residuals. These residuals show that the actual longevity of an animal should be within 6 years of the longevity predicted by the least squares line. Let's see, that looks to be, those are our biggest differences from actual to predicted. Suppose you selected a type of animal that is not included on the original data set, and the gestation time for this type of animal is 270 days. Substituting x equals 270 into the equation of the least squares line, you get 17.4. predict the longevity of this, the predicted longevity of this animal is 17.4 years. Let's talk about it. Think about what the actual longevity of this type of animal might be. Could it be 30 years? How about 5 years? We said that, let's see, what did we predict? 17.4. We predicted 17.4 years. If you look at the table where we calculated all the residuals for each animal, the largest difference we had was 5.9. If we added 5.9 to 17.4, we would get 23.3. If we subtracted it, we would get 11.5. So I would assume that the highest, with the error that the residuals show for every animal that we have actual data for, the error is plus 5.9 and minus 5.9. And if I've predicted a 17.4, I can't imagine the actual longevity being 30 years or 5 years. It's too far away from the prediction. Judging by the size of the residuals in our table, what kind of values do you think would be reasonable for the longevity of this type of animal? It's what I calculated above. 23 to 11 years. I probably could have written that backwards. It really should be 11 to 23 years. All right, continue to think about the gestation times and longevities of animals. The gestation time for the type of animal called an ocelot is known to be 85 days. The least squares line predicts the longevity of the ocelot to be 10 years. Based on the residuals in example 3, would you be surprised to find that the longevity of the ocelot was 2 years? Yeah, I'm surprised. I think that's pretty unlikely. I would say 10 minus 5.9 would be the furthest you would get, which is 4 years. If we had 2 years, that means the residual is 8, which is more than the errors that we found in any other animal that we have actual data for. So I would say 5 or 4 years would be the shortest longevity, and then 16 years would be the longest longevity. So we know the actual longevity of the ocelot is 9 years. What is the residual for the ocelot? The residual is actually negative 1 year. It would be 9 minus 10, which is negative 1, is the residual. All right, summarize. When a least squares line is used to calculate a predicted value, the prediction error can be measured by the residual equals the actual minus the predicted. On the graph, the residuals are vertical distances of the points from least squares line, and the residuals give us an idea of how close a prediction might be when the least squares line is used to make a prediction for a value that is not included in the data set. Good work today. What's that? Oops. You have to go outside. Hold on.